Now that we have the difference between dependent and independent events down, we should talk about the formulas we're going to use. When we talk about the probability of one event happening and then a second event, we're talking about the product of probabilities. Whenever the word "and" is applied to a probability problem, it becomes a product. It becomes a multiplication problem. So let's talk about a classic independent series of events. Flipping a coin. The probability that I flip a heads and then a second heads. So probability of one and then the other. Probability of a head is a half, 1 out of 2. And then the probability of it happening a second time, 1 out of 2. The probability then of flipping a head followed by a second head, or heads and heads, is 1 in 4. A quarter of the time we expect that to happen. Now, this is not just out of 2 flips I had 2 heads. This is specifically referring to a series of events. Now, that's important to note because in later probability, we do deal with the possibility of having 2 out of 3, and it doesn't matter which 2 we're talking about. Any 2 out of the 3. Those probabilities are going to be unique. Let's do another one of these independent events. Probability of drawing out a heart and a heart with replacement. Now again, I have to specify that I'm replacing the card when I draw it out of the deck, because otherwise I create dependent events and those are different. So if I'm going to be replacing the card, this then becomes 1 in 4 times 1 in 4, or 1 in 16. Probability is not really very high in this case. Now, where does the 1 in 4 come from? Well, there are 1 suit out of the 4 suits is a heart, and there are a total of 4 suits in the deck. If you're still a little fuzzy on the whole probability when it deals with cards, let me rewrite that slightly different, make it a little more obvious. In a standard deck of 52 cards, there are 13 hearts. Since I'm replacing the card once I've drawn it, on my second draw, there are still 13 hearts in the deck. So again, I haven't had to deal with any change in these probabilities. 13 out of 52 reduces to 1/4, which takes us now down to 1/16. Let's talk about one more set of independent events as far as probability goes. And again, we're going to continue to use this rule that I'm going to multiply the probability together when it comes time to find my final probability. Earlier I talked about the probability of safely bungee jumping. We're going to work in terms of a decimal. So 0.98. So what would be the probability, assuming that the bungee cord doesn't change on a given jump, of having 3 safe jumps in a row? So that's the probability of safe, and safe, and safe. 3 safe jumps in a row. In order to get the probability of an event, and then an event, and then an event, I'm going to take their product. So 0.98 to the 3rd power, basically. As you can see, my probability is starting to slide down. And again, notice I haven't changed the probability on each sequence. When we're talking about the word and we're talking about events that are independent, I simply take the product of the probability of that event occurring. In this case, 0.98 times 0.98 times 0.98. If we go a little bit further with this, as you can see, I'm multiplying 0.98 by itself over and over again. let's talk about having 30 safe jumps in a row. So 30 safe jumps repeated. Well, that means I'm looking at 0.98 times itself times. Well, we know how to abbreviate multiple products by factors as big as 30. If I'm going to multiply it by itself 30 times, I'm talking about an exponent. So 0.98 to the 30th power, oops, not 3, 30th. .54, about 50%. Now that's the probability of going 0.98, and then 0.98, and then 0.98, and then 0.98, a total of 30 times. Because remember, as I repeat my events, I have to take into account the fact that I'm taking the product of all of those events along the way. I'd like to look at one last example to close this whole thing up in order to look a little more at the kinds of questions you're going to see on the homework and on the test. Okay, I have a standard 6-sided die and a spinner marked off 1 through 4. I want the probability that I'm going to roll a 4 or more and spin a 3. Remember, the word "and" denotes a product. So, in this case, the probability of rolling 4 or more, there are 6 outcomes on the die. Of those 6, 3 of them are 4 or more. Specifically, 4, 5, and 6. So the probability of 4 or more is 3 out of 6. Times, because I'm using the word "and", spinning a 3, 1 in 4. This is going to give me 3 over 24, which is 1/8. And then I can convert the 1/8 into a decimal or into a percentage as required. Remember, the word "and" denotes product.